What I would like to present today is some discussion about the scientific method and the issue of evidence-based practice and what they mean. I find that often there's disagreement, often there are accusations thrown about, and people are fuzzy in their understanding of these two terms. The scientific method works like this. It goes according to these steps in this ladder. Firstly, you'd observe something. You'd notice, oh, this is something new. I haven't seen this before. Oh, then you'd ask a question. I wonder what it is, how it behaves. What does it do when you interact with it, when you push it, or when you pat it, when you interact with this thing? How does it behave? What is the nature of it? How far can I push it? How far can I roll it? Whatever. Then, in order to find out more, you would think about, have I ever seen anything, is there anything in my experience that tells me more about what I'm observing here? So you call on existing knowledge. You then come up with a hypothesis is, oh, right, based on what I'm reading, based on what I've heard, based on what I see, and what I'm thinking, this is my hypothesis about this thing I'm observing here. But now, to be scientific, you don't stop there. You've got to test your hypothesis. So you formulate an experiment and you decide how you're going to prove that what you think is indeed so. So you formulate this experiment, you make sure you've done it in a good, there are scientific guidelines about how you should formulate an experiment, a good experiment, and then you run this experiment to test your hypothesis. After you've done your experiment, you will have information, data. And this data, then, as you study this data, will either accept your hypothesis or it will oppose your hypothesis. You'll have to reject it. And so you would draw conclusions based on your hypothesis, whether what you think is true or untrue, whether there was more information that you should have taken into consideration. And this is the thing with the scientific method. You write a report. You either make a verbal report, but preferably a written report, and you publish it somewhere if you can, to share your results and your data with the wider community. And this is how knowledge is added to and continues to grow and becomes more reliable. But as you notice, there's nothing in the scientific method that says that you should change the slightest thing in your life after noticing all this data. It may be very interesting data, but it might not necessarily change your practice. That is why of late we've been preferring to talk about evidence-based practice. Now, evidence-based practice is slightly different from the scientific method, and you'll see how. It's a conscientious, problem-solving approach to clinical practice. There it is. It's taking evidence and putting it and using it to solve a problem in your clinical practice. You've got to apply it. It incorporates, number one, the best evidence from well-designed studies as per the scientific method that we looked at earlier. The patient values and preferences. What does the person like, prefer? Do they want medication or do they want to go with alternatives? And the clinical's expertise. What you, as the clinician, in your experience, what you would suggest as the best approach for this particular client. So it's not just taking the data and thinking about it. You have to apply it, and you take into consideration what the patient wants and you as a clinician, what you think would be the best. Now, data is a funny thing, and information is a funny thing, and it does seem to me that there are different classes of information. I mean, there is the information that is just interesting, really, wow, kind of information. Gee, I didn't know that. But it doesn't really, I mean, it's interesting, but you walk away from it, and it doesn't really change what you do. But there is the other kind of information as well, the kind that must change what you do, because you can't just walk away from it. It isn't just interesting and bye-bye. Let's look at the first kind of information. And then, being scientific, I went home and I reported to them at home what I had seen. So I made my report. But do you know, there was nothing in my life that changed as a result of seeing this gold car. It's a pleasant memory, but there's nothing that I did to my car. I didn't go and paint it gold. I didn't put a gold stripe on it, a gold strip. I didn't put a gold sticker on the dashboard. Nothing in my life changed just because there was some new information. However, there's that other kind of information, the kind that does change your life. For example, most of us can remember the first time we encountered wasabi paste on our plates. Usually it would be, say, at a restaurant, and we suddenly find that they've brought us our food and there's this blob of green stuff on the side. So we would have the scientific method, being good scientists as we all are, and we would observe it. We'd push it perhaps, and we'd say a question. Oh, I wonder what that is. We'd think about the last time we saw something green and gushy on the side of our plate, and we'd come to a conclusion. Oh, we'd hypothesize that this thing that is on my plate now, this must be avocado, because that's the only green thing that people serve up on plates, right? We formulate our hypothesis about it. We then design an experiment to test our hypothesis. So we pick up a spoon or a fork and we put a blob of this green gushy stuff in our mouth. That is our experiment to test our hypothesis. Well, instantly we are given data that very quickly tells us that our hypothesis was wrong. We have to reject it because what we've got in our mouth at that moment is not avocado. In fact, our sinuses might be on fire, our eyes are watering, we can't catch our breath, and we can't talk. So eventually, when we can speak again and think clearly again, we come to the conclusion that that green gushy thing was not avocado at all, but it was a beast of a totally different nature. And we might, if we're really kind, report to our friends at the table, oh, be careful, that is not avocado, go carefully with it. So again, we have performed our scientific steps, but this information for the rest of your life informs how you behave toward green blobs on the side of your plate. You don't just attack it as though put it in your mouth as though it were avocado, because you remember there's a different kind of green thing that would set your head on fire if you put it in your mouth too fast. It changes what you've done or will do. It changes what you'll do for the rest of your life. Now, as good scientists, that's what we do. We would expand our knowledge base by adding to the information. That's how we learn new things. Unfortunately, what happens in the scientific community, in fact, I want to say the so-called scientific community, people who pride themselves on being scientific, but when faced with information that they don't like, don't approve of, and would really much rather not have known, they simply ignore it and walk away from it. There is also the other kind of scientists. I personally have encountered them. I know that many scientists and researchers and people working in clinical practice have had kind of experience where, how dare you bring us something new, and who are you to bring us something new, and let's hunt you down and make it disappear for all time. We never want to think about this again. Not really part of the scientific method, I think you'll agree, given the preceding information. It is normal for scientists to differ with one another. They can differ and still be scientific. It's the interpretation of the evidence or the theory being considered that we can differ on. Different scientists might publish conflicting experimental results, or they might draw differing conclusions from the same data. This is scientific still. Ideally, scientists should acknowledge such conflict and work toward finding evidence that will resolve their disagreement. This is a quote from the National Science Education Standards document of 1996. There it is if you want to look it up. So therefore, having a different interpretation of the facts is of itself not making those facts unscientific. In fact, I'd like to take that a bit further, just because of the experience I've had and many like me, that just because the boss doesn't agree with what you've proposed, doesn't agree with his theory, doesn't like it, doesn't endorse it, does not make this evidence unscientific, no matter how much they might say, oh, this is unscientific. Just because they say so doesn't make it so. It has been my experience that often people in charge of organizations or clinics or centers will have their information from going to speak to someone whose opinion they admire, some colleague, someone at a university perhaps, who hasn't read the data, but has an opinion. Very lovely scientific method there. And will say, oh, but this is unscientific, it's completely unproven. And so the head of department would trot back to you and say, oh, no, this is unproven, it's not scientific. Just saying it's unscientific does not make it so. Be on your guard against the people who actually haven't even read the information themselves, but have only taken their opinion from some other person who hasn't read the information. Be on your guard. Unfortunately, these people are frequently in positions of power and might try to get you into trouble. But please, if you know, if you have a good and solid understanding of the scientific method, if you understand what evidence-based practice is, then you might be in a better position then to stand your ground and not just be pushed over. Thank you very much.